So, yes, this morning is a bit rusty in PyCon Italy. It's nice to see it. So, who am I before beginning? I'm Joe. I use Python like since 2010, something like that. I mainly code as a web developer, and I'm currently infrastructure engineer, so I also do quite a lot of stuff like on that side of the spectrum. I'm an open source contributor, like for 10 years or something. Yeah, and that's it practically. So, what is Granian? As the title suggests, is an HTTP server for Python application. It implements at the moment HTTP 1.1 and HTTP 2 protocols. It does SSL termination, it supports WebSockets, and it supports several, let's say, application protocols. We will see in detail what does this mean. And what about the name? So for the one of you that are not like Harry Potter fans, it's like a creature from Harry Potter. Why such a name? Just because, you know, it seems that all the servers has like creatures name, like unicorns and that kind of stuff. So I said, whatever, okay, let's pick a name which is comparable. So, the big elephant in the room. Why does Granian exist? Because as someone pointed out on Hacker News, apparently there is no need since Python has already an HTTP server. Thank you for noting me that. But I mean, more seriously, it's a good question. There are already some options out there, so it's not necessarily immediate to build a new HTTP server. So to explain that, I want to go a bit back in time. So let's say that unless you've been living under like a rock in the last, I don't know, 8 years or something, we started switching web development in Python from asynchronous paradigm with WSGI to asynchronous paradigms. So I think ASGI is the first draft is from 2015, something like that. But yes, so we ended up creating, let's say, a new application protocol to support the async and wait flow, etc. And that's one of the reasons why Granian exists. Because in 2021, couple of years ago, so the available servers, at least the ones I knew of, were Daphne, which is the original, let's say, server implementation made by the Django community, which is also like the reference of the starting reference for the ASGI protocol. Daphne, I mean, it's actually nice because it supports HTTP2 since like quite a long time. But in my experience, let's say that it doesn't really play well with high concurrency. It doesn't really support like multiprocessing, several threads, stuff like that, at least that I know of. There is Uvicorn, which is the most popular solution, let's say, for ASGI applications. The nice thing about Uvicorn is that it has like Cython, let's say, library to parse the HTTP request, so it's quite performant. The downside is that it doesn't support HTTP2, or unless you write a protocol for that. And then there is Hypercorn. It's like the youngest of the three. I mean, it is a really nice, let's say, piece of software because it's the only existing HTTP server for Python application which supports HTTP3, actually. On the other side, let's say that the performance of Hypercorn, at least from benchmarks around, is not like very good. So that was the, let's say, the context in which I started reasoning about HTTP servers in Python. And in addition to that, I also maintain a web framework, which is called Emmet, not super famous. But I really wanted to support HTTP2. So actually, in Emmet, since fall 2020, I wrote, let's say, a custom HTTP protocol for Uvicorn based on the H2 library. But the final result wasn't really compelling. I mean, it suffered like a lot for performance issues. It was not even very correct implementation because, I mean, HTTP2, it's quite hard compared to the version 1 because you have streams and you need to handle like quite a lot of stuff in concurrency. It wasn't easy. The solution wasn't really good. And in the end, it seemed like I need to choose between having like all the features I wanted or having the performance I like to have. And that's where the idea came to maybe find a different, let's say, way of handling HTTP requests in Python. And at the same time as I was starting like learning Rust, so let's say that the two things came together at a certain point. And I also in Rust found like a very good library for working with HTTP, which is named Hyper. And so I said, you know, why not? Let's try. And so the final rationales on why Granian exists are this one. So to have, let's say, a single correct HTTP implementation regardless of the version, to have a single package that is working on, let's say, the same way on all the platforms. I don't know how many of you needed to run servers on Windows, but in general, let's say, it's like a different story. And also, one thing I always disliked is like you need to put together several packages to run your application. So let's say you use Uvicorn, but you add the HTTP tools optimization, and you also maybe want to add Gunicorn to have like, I don't know, workers management, etc., etc. My point was to have also a solution that was deployable like on the edge. Let's say I don't know, I have very few hardware resources, I don't want a proxy server or whatever, so I can just deploy it on the end. And all of this with, let's say, comparable performances on the existing solutions. Because again, when I started, it was like, I'm learning Rust, I have an idea, let's see how it plays. So how Granian is actually built. To see that, the starting point is the event loop. Because let's say that in the asynchronous, let's say, world, every HTTP server actually uses the event loop, let's say, primary function to listen to TCP sockets or stuff like that. So a typical, let's say, Python asynchronous servers is actually something which runs infinitely on the Python event loop. And so every, let's say, step of the request are run as coroutines over the loop. So like the listening of the TCP socket, the processing of the request, the run of your actual application code, the streaming of the response, etc., etc. And what Uvicorn does with HTTP tools is actually use C to optimize a very specific part, let's say, of this flow, which is the request parsing. But I mean, the logic is still the ones you saw. So everything is run through Python code. There are some C optimization in the C Python library, etc., but let's say everything runs on your main thread in Python. And so Granian is a bit different because actually the things we saw are actually run into Rust. So there's the Rust Tokyo runtime, which is comparable to the Python event loop, which handles, let's say, everything, but let's say your application code. So when you run your application with Granian, you actually have two different event loops, and the Rust ones schedule, let's say, tasks to run on the Python one, which the only thing that does at that point is running your application code. So let's say that the major difference here is that there is no Python code involved at all except the ones you wrote in your application. All the threading and stuff is handled by Rust itself. So I like to say that everything is like offloaded from Python to Rust, everything that is not written by you. How this is made? With the tons of actually good libraries. So there's the Tokyo runtime, which is the comparable thing to the event loop. There is Hyper for HTTP, Tungstenite for WebSockets, and PyE3, which is the, let's say, #1 library you want to use when you need to talk with the Python interpreter and stuff like that to make extensions. There's also an asyncio package for PyE3, which lets you make every communication asynchronous, even between Python and Rust, or eventually, I don't know, sending awaitables to Python or awaiting Rust futures from Python and stuff like that. So just briefly, this is just some weird looking code. Is just to let you know how does it look like. Let's go to the main topic here, right? But before showing you the numbers, I want to make a couple of, let's say, warnings. The first one is that the aim of this benchmark is not to, let's say, stating that Granian is superior to Uvicorn or stuff like that. It's not about putting Uvicorn in a bad light. In fact, Uvicorn and Granian are so different in the architecture that it's kind of like comparing apples and oranges. I mean, the purpose they do is the same, but they're so different that just keep that in mind, okay? It's not about saying what is the best. So, first chart. So, a very simple benchmark. This is like plain text, I think 4 bytes response across like Granian, Uvicorn, both with HTTP tools optimization and the standard, let's say, package, and Hypercorn. These are proprietary benchmark, meaning run on my machine. single process, so to not, let's say, make assumption based on concurrency, just a single process, that's the result. There's also some external benchmarks. These are run by Tech and Power. There is a benchmark suite that gets continuously run with tons of frameworks. Yeah, this is also with the JSON response to enlighten, let's say, the CPU bound usage. So the results, it's kind of 5.7 times Uvicorn without anything, and from 25 to 47% performance increase over Uvicorn with HTTP tools. WebSockets. So WebSockets, let's say that with a single process, you can expect something like 80% more concurrency increase over Uvicorn. Those are messages per second processed by the server. And the resource usage, which is one of the point actually, because instead of having Python running everything, you actually rely on Rust. I don't still have, let's say, proper numbers because the project is actually quite young. I mean, the first version release of Granian is from November last year, so I still have to collect data. So from, let's say, some tests in my company and software like that, there's a 10% increase in RAM usage on a tiny application. Like the base is 65, so you can expect something like 70, 72. And major reduction in CPU usage on the average. The numbers we saw on a couple of services with ASGI protocol is kind of like that. What about HTTP2? So HTTP2 is very hard to benchmark, so I don't have proper numbers here as well. But let's say that from the preliminary tests, you can expect like 6 times the performance of Hypercore. But there is still a but here. And the but is that ASGI is designed to be run on Python. So I ended up designing a new application protocol. And to quote XKCD, I know that every time someone invents a new standard, is like, yeah, there's just another standard. But let me say about the issues I found in supporting ASGI protocol in Rust code. The first thing is that ASGI is all about events. So the server and the application speaks with these dictionaries, which contain like some preset of keys, like the type of event that is happening. And so this ends up usually having like quite a lot of if statements on the protocol side, let's say, of the server. And the other thing is that not actually all the events are doing I/O. So the interface is the same. So the send, let's say, coroutine you speak with is unawaitable. So of course you need to await. But in this example, when you send a response via HTTP in ASGI, you have 2 calls to make. The first is about headers and status code. And that call actually doesn't need to be asynchronous. So that means that you are actually putting into the loop something that doesn't really need to have all that machinery. So I invented the RSGI, of course, because it's Rust Server Gateway Interface. So the idea is actually to have a single protocol object with several methods. And it works. I mean, I think that the interface is quite solid at the moment. But the advantage of this is that actually it gives like a lot of performance on the results, because on top of Granian being faster on ASGI, it could actually be even faster with a different, let's say, protocol implementation. And another good thing about RSGI is that it can offload the static file serving. So if you have static file like CSS, whatever. And this is pretty good. This is a test I ran on Emmet, so the framework I also maintain. The 2.4 version was using Uvicorn with HTTP tools. The 2.5 uses Granian in RSGI, and it makes like 28 times faster serving of static files. So that's very cool. A big warning here. So RSGI is not intended, because some people ask to me like, explain me why you need a new protocol, but it's not targeting like actual developers. Okay, so in the same way, when you build web application, you don't actually think about ASGI because it's behind the framework you use. The target audience for our SGI is actually framework developers. So if Starlet like to implement the RSGI interface, you can use it on Fast API for free. What about WSGI? Yes, I have it as well. So actually the code is even simpler because you don't have the Python event loop running. So it kind of behaves like Gunicorn with greenlets. And if you want to use with WSGI, please wait the next version, because at the moment it doesn't actually iterate the response body. So if you're streaming like large bodies, don't do that. And the performance is like comparable. Like 4% increase doesn't really matter. Does it scale? Just to close it. I don't know. I don't know. I mean, using multiple threads, etc., doesn't really seems to make a big difference. Just quickly to close it up, what I learned from all of this, Rust is actually fun. It's quite simpler to write Python extension compared to C and Python. It has an impressive community, like the cargo and packages and support, it's awesome. PyO3 is super quick to learn. And just a few months got me having this performance, so nice. It's also hard. If you saw the previous talk, there are some things that are not so easy from a Python point of view. Writing performance code is like art. You need to take a lot of decisions that you actually usually don't care. Threading is super hard. Even my assumptions. So I assume to gain performance by leaving multi-threading on the Rust side, but actually it seems to not make such a difference because probably, I don't know, the GIL or something, and I don't really know. Asyncio and internals are like a mess. There's a lot of objects, like you have handles, futures, tasks. The magic behind the await statement is like huge. Context vars, it's dark magic. 0.4 of Granian is yanked actually as a release. You need to use 0.042 because 0.40 leaked context, because yeah, I didn't understood so well how context var was working. And FFI and CPython internals are not required, but probably it's nice to know them. That's it.
All right. Thank you. Yeah, I'm sorry to have to cut you off, but like we had the problems and everything. I'll read the questions that got the most votes. So are there any performance issues on marshalling serialization or deserialization between Rust and Python structures?
So you have a bit of overhead in converting, let's say, bytes and strings to and from, let's say, Rust. But since Pyo 3 relies on FFI, it's not so much, at least from the numbers, let's say that's not the problematic part about performance.
The second question, does Granian support request timeouts? Can it kill a thread that has been processing a request for more than, for example, 1 minute?
Not really. That's usually left on the framework, let's say, implementation that uses Granian. On this, I just want to add that since you have two different loops, you cannot actually block the Rust one, because when it runs like the actual Python code, you cannot like block the other one.
How does Granian compare to Robin?
So I think that the behind the scene is quite similar, because Robin uses Sactix behind it, which uses Hyper behind the scene. But the scope is very different, because Granian is not like a framework. So it's just about giving you a server implementation you can use on your application. It doesn't force you to use a specific, let's say, framework language to building your application.
Okay, thank you so much. Please catch the speaker in the calls and ask him other questions. Thank you so much.
Thank you very much.